At this time, I would like to introduce Professor Lee Lynd, the Paul E. and Joan H. Quinault Distinguished Professor in Engineering, Environmental Engineering Design, and Adjunct Professor of Biology at Dartmouth College. Professor Lynd is here.
Great, thank you so much. It's a pleasure to be here. I'd like to add my welcome to the alumni who are taking an interest in the school and spending some time with us on this beautiful Saturday. I'd also like to mention, I'm not that much of a rah-rah person, but it is a very, very exciting time at Thayer School, and I really believe in the direction we're headed, and I think Joe's doing just a great job. So I'd like to tell you a little bit about biofuels, and as I thought about it, I could spend time telling you what we're doing or why we're doing it, and it's a little hard maybe to get interested in the what without the why. So I'm going to talk mostly about the why and a little bit about at least the level of activity that we have, and try to give plenty of time to ask questions. So I call my remarks Bioenergy in relation to the great challenges of our time. Interesting question, I think. A few hundred years from now, when people look back on those alive today, what will they think we should have been paying attention to? And I'm going to be presumptuous and say, above all others, I think two things. One of them I call the sustainable resource revolution, which I'll elaborate on, and the other one's poverty. It's fairly straightforward to say what success looks like. In the case of the sustainable resource revolution, which goes beyond energy but very much includes energy, reliance on resource income rather than resource capital. In the case of poverty, households able to buy what they need. Each one has profound ethical dimensions. The impacts and actions of actions and inactions on future generations, and geographical and socioeconomic inequities. The poor generally have little voice and the unborn none. My favorite quote about ethical behavior is from Aldo Leopold, the great conservation biologist: doing the right thing when no one is watching, even when doing the wrong thing is legal. And I'll add one more of my favorite quotes that I think Thayer School is progressing towards embodying. If engineering is the application of science for human benefit, then the engineer must be a student of not only the application of science, but of human benefit as well. So I'll let you read these global poverty indicators, although they're shocking. There's a lot of written these days about most of the wealth of the world being in the hands of a few people. But to me, the most striking, I turned it off, okay. To me, the most striking is over here. So this blue, going back to 1820, inflation corrected, the blue refers to the spending power per capita or GDP per capita of the 5 richest countries in the world, and the gray at the bottom, which has gone nowhere in the last 200 years, is the poorest countries in the world. And so I think, although there have always been poor people, I think that we have a distinctive circumstance today. In terms of this resource revolution idea, we've had two in the past in human history. The first was the Neolithic Revolution. The second was the Industrial Revolution. And I think there are a lot of indications that in something like this century or the lifetime of people alive today and coming into the earth, that we're going to need a third one, the Sustainability Revolution. Some interesting observations, which I won't, which I won't take too much of your time. But to navigate this smoothly for all sectors, it seems to me, and this is saying the obvious, and yet it's surprising to me how often we try to find solutions without changing. We need to do things differently than we do them now. We need to take a systemic approach, and we need increased efficiency along all steps of the supply chain. And the first step to change is to recognize that it's possible. And I actually spend a good fraction of my time in the bioenergy field trying to address that. There's a lot of numbers here, but the take-home message, if you look at the bottom line, so these are 7 different metrics of environmental impact, and looking at various consumer activities, and essentially 3 consumer activities account for about 3/4 of environmental impact across the board. This is data for the US. And those are personal transportation, food, and essentially household energy use. Here's a global view, the human footprint. Notice on the right, and what this is, to elaborate a little bit, the footprint is the amount of land that would be necessary to sustainably provide for a given activity or waste assimilation. It's not the amount of land we necessarily occupy with that today. And once again, energy and food. When you talk about environmental impact, energy and food are absolutely the lion's share, and everything else by comparison is small. It's also interesting to note that currently humanity is functioning at about 1.5 Earths by this calculation, which actually was started by a graduate student, Matisse Walkernagel, at the University of British Columbia. So this century of biology, as it's often called, also needs to be the century of the sustainable resource revolution and the century of the end of poverty, which we're actually making some progress on, as indicated globally, as indicated by the cover of The Economist recently. But just to remind you how fundamental food and energy are, not only to the environment, but hunger kills more people than AIDS, malaria, and TB combined, stunts growth, blunts human initiative, and causes suffering for many more. Energy access is recognized as a key enabler and constraint for economic development. That's true in developed countries. We heard Barry McLean asking a question about the cost of electricity in Germany yesterday. It's very much true in developing countries as well. This from the United Nations Development Program. Energy is central to sustainable development and poverty reduction efforts. It affects all aspects of development, social, economic, and environmental, including livelihoods, access to water, agriculture, productivity, health, population levels, education, and gender-related issues. None of the Millennium Goals can be met without major improvement in the quality and quantity of energy services in developing countries. So what does all this have to do with bioenergy? Well, you've got a very complex nexus consisting of these elements and more: food, development, social aspects, environmental aspects, technological aspects, land management. This is a very complicated set of interrelationships without bioenergy. And if you plunk down bioenergy in the middle of it, surprise, surprise, with all of these connections, you can, depending on how you do things, get positive or negative outcomes. This is a quote from a paper that just appeared. I was honored to lead with a group of mostly Africans and Brazilians, actually. Bioenergy production requires land and is thus inextricably linked with social development, agriculture, and environmental quality. These linkages increase the complexity of analysis and deployment of bioenergy and can result in undesirable consequences if managed poorly. And this is maybe the most important point. If managed well, though, they have potential to greatly multiply benefits far beyond energy provision per se. And so we're going to need bioenergy. I don't think it's actually appreciated. There's remarkable consensus that at least if you think the world has a carbon problem and a climate issue that needs to be addressed, those who try to imagine what a low-carbon world would look like have a really difficult time doing it without bioenergy. This is a figure from a paper in Science published a long time ago, but the basic idea is that photosynthesis removes carbon dioxide from the atmosphere before the products of that would be returned, for example, by combustion, so you have the potential for a sustainable cycle. So these are data from 5 low-carbon energy scenarios from a variety of organizations: International Energy Agency, Global Energy Assessment, International Panel for Climate Change, the World Wildlife Fund, and Greenpeace. Let's only focus on the blue bars. These are the percent of energy supply in low-carbon futures by 2050. Bioenergy is about 1/4. It's really hard to imagine a low-carbon world without bioenergy. And in fact, all of these studies take on other renewables first, which I support. I mean, if you can do things other ways, cost-effectively and functionally, we got enough other uses for land. Let's do them the other way. So all of these take on other renewables first, and they still come up with this. This is a complicated graph, but over here we have personal light-duty vehicles, buses, rail, air, road freight, rail, and water. Projections, according to the International Energy Agency 2-degree scenario, out to 2075, which is a long time. The reason to go that far, though, is if you go look earlier, you don't have enough time for change to occur, so you're kinetically limited to a very large degree. So there's huge error bars on this, but nevertheless, it's important to think about. And again, this is an other renewables first approach. If you can do it with hydrogen or batteries, do it. And so if you look at the bottom, very large percentages of these, this is for transportation energy, very large percentages of transportation energy provided by renewable sources other than plant biomass. Incidentally, how many of you knew that ocean shipping consumes more energy than aviation now and is expected to do so in the future? I don't think that's that widely known. But although many of these modes of transportation can and maybe will be provided without biofuels, when you talk about aviation or ocean shipping and to a significant extent road freight, it's extremely hard to imagine a battery-powered jet. And indeed, the longer you go between refueling, the more you value a liquid fuel. It's that simple. If you go across an ocean, you really have a hard time doing that without liquid fuel. So if you add all of these up, and let's focus on 2075, roughly half the transportation energy utilization in a low-carbon world would need, or provision, would need to come from biomass. And if it didn't, if we used fossil sources instead of biomass, that little gold there is the level of emissions for the 2-degree scenario. So if we use fossil sources for that lower bit, the sort of Band-Aid color band there, instead of biomass, we would exceed the allowable emissions for a 2-degree scenario by a factor of 2, even if all the other sectors were carbon neutral. As far as land, this is something I've learned an awful lot about lately. But basically, the world spends about 5 billion hectares, or uses about 5 billion hectares to feed ourselves. About 3.5 of that is classified as pasture, although not all of it has animals on it. And about 1.5 is classified as cropland. But what this curve here is, this curve represents, for a given value of land, the value on the x-axis is the cumulative amount of food from all land less than that. And so basically, we feed the world on about 1 billion hectares, and according to the FAO, we have about 1.4 billion hectares of cropland that is not now potential cropland, not now used for crops, and we'll need about 5% of that to feed the world in 2050, and thereafter, the pressure on that land will decrease, according to the FAO. So there's a perception that we don't have land, and that can grow things, and by and large, there's a lot of subtleties to this, but by and large, I think that perception is wrong. I've spent a lot of time working with people in developing countries, thinking about food security, and the FAO in the last 10 years has adopted these 4 key words: availability, access, utilization, and stability with respect to food security. They have definitions of those. I find those words actually to be quite opaque in general with respect to food security, and I find them particularly to be opaque with respect to informing bioenergy. A much more useful perspective, for my purpose at least, is this book by Roger Thoreau and Scott Kilman, an interesting personal story. I know Roger Thoreau. He was a 30-year Wall Street Journal reporter, and he was assigned to study famine in Africa. And he got so outraged that he quit his Wall Street Journal job, and he's now a full-time food security person. But he talks in great detail in this book with the rather descriptive title, Enough: Why the World's Poor Starve in an Age of Plenty. He talks in great detail about the causes of food insecurity, headed by poverty in its various guises, but infrastructure, and especially market infrastructure. People think of infrastructure and they think physical, but the market infrastructure is critically important. And the interesting thing is, this is very summary, I realize, but if you look at the impact of bioenergy on these causes, depending on the flavor of bioenergy, the vast majority of these impacts are positive. And so there's a lot of discussion with the New Partnership for African Development and other parties about trying to use this as a catalyst to promote agricultural development and increase food security. So, last slide, what is my group, what's happening at Dartmouth in this? And I'm happy to talk about any of this more. We have one of the leading laboratories in the world in research on the fundamentals of microbial cellulose utilization, because the most prominent component of biomass is plant cell walls, which are composed of lignocellulose. We have, I think it's fair to say, the leading group worldwide in one-step consolidated bioprocessing, where essentially you do things in a very efficient and quick way without adding enzymes. And it's widely regarded as a potential breakthrough, and many people would say the potential breakthrough in low-cost processing of inedible cellulosic biomass. And on the right are some of the things we're actually up to. In terms of resources, food, and environment, we're co-leading global teams analyzing, actually a Proceedings of the National Academy of Science paper came out about a year ago, the miles per ton of biomass for electric and biofuel-powered vehicles, the potential for sustainable intensification of pasture land, impacts of dietary change on land sparing and greenhouse gas emission reductions, and the need for bioenergy in a low-carbon world. And finally, I've started 2 companies now, co-founded to be precise, and Chief Scientific Officer and member of the Board of Directors, first Mascoma Corporation and now Enchi Corporation. And then again, increasingly, this whole notion on development, where I'm privileged to be part of a network of people around the world looking at analysis of the potential role of bioenergy to enhance human well-being in the developing world. So again, welcome back. We're really glad to see you, and I'd be happy to take any questions you might have. Thanks. Yeah.
What are you producing? Then can you convert it to, I'll say, mobile energy or something spinning?
Yeah. In the transportation area, I think the highest demand for liquid fuel is for liquid fuels. I think the first one you'll make is it will be feasible to make is ethanol, and I think in the long run you could make a variety of other molecules. One can also co-produce electricity along with ethanol. Interesting statistic. Right now, Brazil co-generates electricity from bagasse, a byproduct of sugar manufacture and ethanol manufacture. The amount of electricity they co-generate is equal to 1/3 of the generating capacity of the 47 sub-Saharan African countries other than South Africa. So just gives a sense of scale. There's a question in the back. Yeah?
As far as input into the process, are you looking at waste products, algae, switchgrass, or all of the above?
I would be surprised. It could happen, but I would be surprised if algae ends up being a practical raw material for large-scale liquid fuel production. And I think grasses, in general, we're looking at stuff you can't eat. And I think grasses have the most potential for various reasons, including partly the availability of land to grow them. Yeah? There was another question, yeah?
What's the focus of Enchi Corp?
Enchi Corp is focused on this consolidated bioprocessing idea using, we hope, revolutionary technology that relies on bacteria, thermophilic bacteria that grow at 60 degrees centigrade or so, that naturally occur in hot springs. And for reasons I'd be delighted to tell you about, we think they have a bright future. Yeah? It's okay.
Was working towards I'll call it semi-works or a small industrial scale. So tell us where you are.
Yeah, interestingly, the story of Mascoma is an interesting one, and it has been a great teacher to me. Mascoma began with the idea that we were going to both, essentially, the analogy might be to write the software and manufacture the computers, but to speak about it not in analogies, we were going to both develop the technology and be the company that deployed it in, hundreds of millions of dollar facilities. In retrospect, we could talk longer about where that expectation came from. It wasn't a very realistic expectation. And so Mascoma's focus now is essentially as a catalyst company, the equivalent of being a software company, and let somebody else make the manufacturing products. That said, Mascoma introduced the first recombinant yeast globally, and in fact the only recombinant microbe used in the commercial fuel ethanol industry globally, and that is in the United States. And I just actually met Zach Lasordo, a graduate of Thayer School and wonderfully bright young man, in the parking lot coming in, and we have very exciting things going. Mascoma has very exciting things going on in Brazil as well. So we're leaving it to others to build the semi-works and whatnot, and we're providing the software. Biological software, that is. Okay, well. Oh, okay.
So one of the issues always with the large-scale biofuels is I'll call it the radius of capture and the fuel consumption and such to usually haul the biomass into if you're consuming a central processing facility model. So in terms of your analyses and such, what is the kind of the realistic radius that you're going to have to go to get a, I'll call it a scaling facility, and then in terms of what amount of generally liquid fuel consumption you're going to burn just to bring your raw materials in. How does that trade off when you look at the big picture?
Yeah, the energy input and output bit, which is part of maybe the smaller part of your question, if you have a feedstock which brings its own fuel, it's very favorable. And actually, sugarcane bagasse is an example because it has a residue that makes the process energy self-sufficient. The transport energy is for typical distances, which would be a maximum of 50 miles, quote, but although it depends an awful lot how you transport it. You can move stuff 100 or 200 miles by train and spend very little energy at it, and about the same as moving it about 15 miles by truck. But in general, I mean, one number is, with a 50-mile radius, which pulp and paper industry gathers from at least that today, you can actually make 5 billion gallons of liquid fuel, which is gigantic. So, in a nutshell, I don't see that transport energy is going to be a big constraint. I do think learning how to make these plants smaller is a really good thing, and there's a lot of engineering aspects. Just for example, if you can avoid a solid boiler, solid boilers cost about 5 times what a gas boiler costs. And so there's lots of tricks to it. I believe that we can move the technology smaller as we learn more about it, and that there will be many advantages in terms of social and agricultural integration as we do so. Yeah, George.
Lee.
Yeah.
So I'm trying to delay the start of my talk as much as possible.
I was pleased to see I was pretty well on time, but go ahead.
What I read in the paper, in my understanding.
Yeah, I read the same papers.
So, part of the reason, who knows what the motivation is, but what I hear is part of it is to sort of undercut alternative energy sources, undercut the Russians, the fracking industry, and so on.
Yeah.
So how's that going to play out? In other words, what are your thoughts about short-term, long-term implications of that sort of manipulation of the market?
Well, I think it has the effect you mentioned, that it slows down development. I personally observed that. I would comment not so much from a business point of view, but from a trying to do good things in the world point of view, that to the extent that the supply situation eases, prices go down, we discover new reserves, etc., the climate problem becomes more difficult. And so, as far as a reason for me to keep going personally, I think that the sustainability challenge just becomes bigger. In fact, you can show very, very, very convincingly that in order to have any reasonable carbon future, we have to leave lots of fossil fuels in the ground. We cannot rely on exhaustion. I'm not sure I know an awful lot more than anybody else in this room. In fact, I think I know less than some people in this room about the future prices. If I had to guess, and it's only a guess, I predict in 3 years they will be well over $75 a barrel. but I wouldn't be surprised if it took 5 years before we saw 100. But frankly, it's not only a probabilistic or estimation, because as everybody knows, it's affected by decisions that we don't know what these, as well as random events. So yes, it has a damping effect on investment in any alternative to petroleum anyway. Natural gas also has a certain impact on the electricity side, but again, because of that climate interaction, I think there are reasons to persist. And well, I'll leave it at that. One more, and then to stay on time, if you don't mind, I think I'm going to, yeah.
Yeah, and there's been some movement toward using biofuels for home heating. In my particular area, there are a couple of suppliers who will sell a blend of biofuel with regular heating oil, and it has interior benefits of less greenhouse gas emissions as well. Do you see any real strong movement in this regard in terms of use? Because a tremendous amount of oil is used for the heating.
Yeah, honestly, I don't think it makes a great deal of sense. In this area, for example, we have lots of forest resources which can be fairly easily converted into a burnable form. Pellets and whatnot can be automatically fed without the cost and energy losses of converting to a liquid fuel. To me, the reason to convert to a liquid fuel is to make it portable. And if you're going to use it in a stationary application, I think there are better ways to use, cheaper ways and more efficient ways to use biomass. So I would be surprised if that took off big time. Thank you very much.